Good morning, everybody. This is Professor Jason Kim. Today's lecture is about estimating, especially about the estimating uh, mean value when sigma is known or sigma is not known. Okay. Now, why do we need to estimate the mean values or mu? The reason is the mean value is a good indicator for us to determine what's going to happen in future or what is the best uh, price to set up for one particular product or what is the good way to find out a very reasonable decisions. Those are all related with estimating the mean value, because as you know, the mean value is from the older data, the one in the middle part, best representing all this data. That was the mean value. So be able to find the mean value give us a lot of advantages or hint about what the future price or decisions that we should make by. Typical example for that is like elections, presidential elections. By having that estimation that who gonna win, always give us a better sense of the who to find out who is gonna be next president as soon as possible. So we do that for uh, by finding a mean vote number of voter that who cast which one that we select as a president of the United States or any country. So now, so we know that estimating the mu, the mean value, is very important in many aspects of our life or our decisions. So then, how are we going to find the, or how are you going to predict the mean value? That's what we try to learn from this chapter. To learn this to find this mean value or predict the mean value, we use this margin of error concept, as well as the um, point of estimate, uh, which we are using for usually using for the sample means. And we also use critical value, we call Z of C in this case. So by using these three um, terms or terminologies, we're gonna calculate or we're gonna get the predict the mean value. Okay, estimate the mean value. So now, how are we gonna do that? Okay, we use the technical form of the confidence interval for mu when sigma is known. So whenever they ask for the confidence interval for mu, we want to have in such a format like this: x bar minus e and x bar plus e. So this mean value is ranged from x bar plus e as higher level and x bar minus e for lower range. Okay. Again, x is a sample mean of a simple random sample, and E has this particular formula that we're going to use. From that formula, we have to find that Z over C, and we're going to use the sigma, we're going to use N in this particular formula to calculate the E value, we call margin of error. So let's practice some of the question. Okay, so now what formula are we going to use? X bar minus E and X bar plus E. That will be the range and prediction to get the mean value. Okay. So when we are done, the mean value will have a range between this and this. Again, what was X bar? X bar was a mean sample. What was E? Well, you have to find the E by using this particular formula. The formula, we're going to use two formulas. One when sigma is known, sigma is not known. So when sigma is not known, for whatever the reason, then we use S instead. So when sigma is known, what we're going to do is the E, the estimation of the margin of error would be G of C, the critical value, and you multiply that by a standard deviation and divide by square root of n. N is the size of the data, as you know. So we're going to use this to find a E values. Okay, so let's do that. Okay, number one, we're going to have range format. Number two, we have to find a margin of errors. And then you add and subtract margin of error from the sample. So that's step three. So we are going to have these three steps. Okay, so now let's look at the example. If X, example one, if X has a normal distribution with a population standard deviation as 10, so that means sigma is 10. That's what they are saying it. So you should be able to dissect this paragraph to get the value of each symbols. The random sample size of 25, because sample size means n. So that means from here, n is 25. Okay. And sample mean of 60, because they say sample mean, so X bar is 60. That's what they're saying. And then finally, they're asking, find a 95% confidential interval for mu. That's what they're looking for. So that means you have to find the mu value by X bar plus margin of error and X bar minus margin of error. So they want to find this. Okay. So to find this, what do? We use a special formula to find margin of errors, right? What was that? The formula for margin of error when sigma is given. So in this case, sigma was 10, right? Is finding the confidence level of this case is what, 95%? So 0.99, 95. So you have to find that and multiply that with a sigma divided by square root of n. That's what we are going to do, right? So estimate for 0.95 is z of 0.95. That you find this one from table number 3b. Okay, and then sigma was what? Sigma was 10, and n was what? 25. So square root of 25. So to get that value, all you need to do is find z of 0.95 confidence critical value for confidence level of 95%. Okay, so now we are going to go to table number 3b, okay, and find this confidence value for, critical value for confidence level of 95%. Okay, so if you go that, here is 3a, table 3a, and table 3b is here. Table 3b is here, and 95 confidence was critical value for 95 confidence was 1.96. So that's how you get that particular value, 1.96. So going back to that, you replace that is 1.96 from the table number 3b. So when you actually calculate this by using your calculator, you end up with a 3.92. So it wasn't that bad. Okay, so your margin of error for 95% confidence interval value is actually margin of error for 95% is 3.92. So now what you're going to do is you're going to estimate the mean value at the range of x bar, which is 60 plus 3.92 with x bar minus 3.92. Okay, so this is sample means. So if you do actual calculation for this range, again, final mu become a 63.92 by adding these two numbers, and by doing this subtraction, you get a 56.08. So what does that mean? That means your estimation of your mean value is between above 56 and 63 or 64. So you can predict or you can estimate what's going to be a mean value would be at this particular condition. So that's what we are trying to do. We are trying to estimate the mean value for whatever the reason from given information. Okay. So now let's look at another example. A wholesale electronic part company, 5 salesperson can see 60 buyers per hour in averages. Assume that average is normally distributed. You always have to have a normally distribution. So we can utilize table number 3A and 3B, in this case 3B, with a population standard deviation as a 10 and random sample of 25. So again, from there, since they say random sample of 25, that's indicating the size of it, so n become 25. And from population standard deviation is 10, so from there we find that sigma is 10. And since you are using 6 buyer per hour in average, so that indicate that x bar is 60 here. And then finally, they want to find the 95% confidence interval of this mean. So what they're saying is, again, they want to find that the mean value with after you find the margin of error, that they want to estimate the mean value. So again, from here, you have to find the E value first, right? Because everything else is known. So to find the E of 95%, you have to find the critical value of 95% times sigma over square root of n. So again, if you do that, E of 95% is critical value of 0.95 again. That was what 1.96 again, times sigma was 10 divided by square root of 25. So when you use your calculator, you got 3.92. So now your estimation become 60 plus 3.92 with 60 minus 3.92. So final estimation of the mu would be 63.92 with 56.08. So you can find the range of the means. So again, it makes sense because it's the estimation. So you don't get an exact number. You get some kind of range because you're estimating it. So it's not going to be exactly same one number. And this is like a margin of error for 95%, so to speak. Okay, so that's how you do it. So now, if anybody noticed already, we have exactly same answer for example 1 and example 2. Yeah, that's right. It's the same question with a different style. This number 1 was like bare bone style, and number 2 is more elaborate style. But they are talking about the same thing. Okay, so that's why you get a same answer as well. Okay. Does anybody have any question on this? Okay, so those are the first example of when sigma is known, how do we estimate uh, the mean values with the confidence level. Okay, so now let's look at another example. So in this case, they said if x has a normally distribution, so again, you have to say it is normal distribution. Otherwise, you cannot use table number 3. Okay. Population standard deviation is 5.1. So that indicates that sigma equals 5.1. So when you see this sentence, you have to be able to dissect and find each values. And they also said random sample size, which means n, so n equals 40 this time. And has a sample mean of 8.2. That means x bar, because sample mean means x bar equal 8.2. Now they want to find out 99% confidence interval. So that means G of 0.99. Okay? So by knowing that, again, to find the estimation, what you have to do is that's x bar plus margin of error with x bar minus margin of error. That's the format that we are using to express the estimation of mean value. So in here, again, you have to find what the E values are. So this particular class, E of 99, is always a G of 0.99 times sigma of square root of n, which means you have to find the G of 99 first, and sigma was 5.1 in this case, and n was 40, right? In this case. Okay. So how they find G of 0.99? Again, we are going to go back to table number 3b. And in this case, 99 is 2.58. Okay, 2.58. So 2.58, it will be replacing 2 here, 2.58. What are you going to, with a proper calculation, you got 2.08. So what does that mean? That means your estimation would be 8.2 plus 2.808 and 8.2 minus 2.08. So your final estimation of mean value would be 10.28 by adding these two numbers and subtracting this, you get 6.12. So your estimation of a mean value for this particular case is between 6 and 10. Okay, so your mean value should fall into these intervals. Now, again, it's the same question in different format. Is this. The random sample of 40 factory workers has a sample mean working hours for 8.2. So random sample, so that give you size. So n equal 40 here. And sample mean value is 8.2. That means x bar equal 8.2. Population standard deviation is 5.1. So sigma equal 5.1. And 99% confidence level is they want to find out the z of 0.99. Okay, so again, you do the same way as what we learned previously, and you get the same answer. Okay, anybody have any question? So now let's get into another format. Now another format is when you have estimation when the sigma is not known. Okay, so when sigma is not known, again, you're going to use the same format, that sample mean minus E and mu is sample mean plus E. So we're going to use the same format of range of it, but when you try to estimate the margin of error, you will have different formula. So how do you find margin of error for when sigma is not known? You use T of C, this case, times S divided by square root of n. So margin of error that you find in this particular case when sigma is not known. So sigma is not known, so you cannot use a sigma. But sigma is not known for many reasons. One, maybe it's too expensive or too costly to find the sigma, or it's not easy to find the sigma for whatever the reason. Okay, maybe it's too big, or maybe locations are not good, or it's in the water, or in a sea, or in a mountain, whatever the reason. Sigma, you cannot get it. But S, which is the population of sample, is much easier to get it because it's a sample. So you can just restrict the area, restrict the size. So sigma is given. So for this particular case, that now we have to use another formula, that which is T of C times sample standard deviation divided by square root of n. Okay? So this particular case, that sorry about that. Let's look at some examples on this. Okay. So this is the two case, that one, when sigma is known, you use this formula. And when sigma is unknown, which means you have to find the S value, and you use this one. Okay. So that's what we are going to do it. Now let's look at some examples. X is a normal distribution with a sample standard deviation is 10. So in here, you can right away, they say sample standard deviation. So it's S, not sigma, S. So S is 10 in this case. Okay? And random sample size is 25. That means n equal 25. And sample mean is 60, which means X bar is 60. So you have to know these symbols. Okay? They want to find out 95%. confidence. That means they want to find that Z by using G of 95. Okay? Now, so again, how do you find the E value? No, T value in this case. Okay, you have to use um, actually E value. How do you find the E value? You have to use T this case because it's a sample standard deviation is given, not population standard deviation is given. So again, we're going to find the mu by having x bar plus E and x bar minus E. Okay, but the way you find the E is a little different because due to the sigma is unknown. So E become, according to the formula, T over 0.95 multiplied by S over square root of N. So E over 95 this case, T over 95 times, what was S? S was 10, what was N? N was 25. Now you have to find the T over 95 from table. But T over 95, you find this value differently than previous. First, you need a C as a 0.95, and you need something called degree of freedom. So in short, we call DF. DF is always n minus 1. So in this case, n was 25. So 24 minus 1 is 25 minus 1 is 24. Okay. So by using these two values at table number 4, we can find T of 95 confidence. So let's go to table number 4 using C as a 0.95 and degree of freedom of 24. So if you go to table number 4, okay, here is a degree of freedom, and they said it's 24. So you go all the way, make a line all the way to 24. And confidence was 95%. So 95%. So whatever meet, you get T of 95 as 2.064. So you got 2.064. So you put 2.064 here. So it's not that bad, you know. So when you actually do the calculation, you end up with a 4.128. So your estimation become x bar, which is 60 plus 4.128 with 60 minus 4.128. Okay. So if you do actual calculation, you end up with 64.13 and 55 and 87. So formats are same, and you finally got the estimation of mean value between about 64 and 56. But doesn't matter if I say 64.13 or 64.128. It doesn't matter. I like to have a 3-digit, but whichever format is fine. Okay? Now, second example is exactly same as first in different format. The wholesale electronic part company, 5 salesperson can see 60 buyers per minute in average. So that means X bar equals 60. That's in average, that's mean value. The sample standard deviation is 10. So from there, we found out S equal 10. So because they say sample. And sample of 25 hours is selected, which means n equal 25. 95%, so they want to find that, in this case, t, right? T of 0.95. So I made a mistake. So this should be t of 0.95. So the second question is exactly the same as first question. So you follow same method. Okay. Any question? So now let's try another set of questions. If X has a normal distribution with a sample standard deviation as 5.1, so from there you got S as 5.1. Sample size is 46, so N becomes 46. Sample mean is 8.2, so that means X bar is 8.2. Since they are asking for 99% confidence, we are looking for T of 0.99. So that is step one. You dissect, you read the question, and from there, you find S, N, and X bar and T values. And then you have to find a estimation of 99% in this case. And you are using T of 0.99 in this case because of the sample standard deviation with the S, because you don't have a sigma anymore, you have S value, square root of N. So if you do that, T of 99 times S as 5.1 divided square root of 46. Now, before we get into table number 4, because try to look for T of 0.99, you know that C become 0.99 because they are looking for 99%. You need degree of freedom because they need this two value to utilize the table, is n minus 1, which is 46 minus 1, which becomes 45. So we're going to use degree of freedom as 45 and C as 0.99. So let's go to table number 4 and look for this value. So degree of freedom was what? 45, and C was 0.99. So 45 is here, and 99% was here, right? So value of T of 0.99 in this case was 2.69. So we're going to bring this 2.69 back and plug into our formula. 2.69, here 2.69. So when you actually calculate, nice and easy for this, you got 2.023. So we're going to use this to create the range of mean value by having X bar plus E and X bar minus E. So mu become, in this case, 8.2 plus 2.023 with 8.2 minus 2.023. So actual range become a 10.223, okay, with 6.177. So that's final answer. So they are saying approximately between 6 and 10. If you round it off, that's fine too. Okay. So that's how you do a example 3. Now example 4 is exactly same as the example 3, just with a different wording setup. So random sample of 46 factory worker again. So n become 46. Have a sample mean working as 6.2, so that give you X bar is 8.2. Now sample standard deviation, so they give you S equal 5.1. And they want to find the 99% confidence. So they want to find the T of 0.99. Okay. Again, this setup is the same as previous setup. So you do the exactly same thing. You get the final answer. Okay. So that's how you do to find the estimate when sigma is known or sigma is not known. Okay. So study this and I will talk to you. Okay. Thank you. That's for today. Study hard.